Welcome to Instrulogic channel. Imagine transferring 10,000 cubic meters of product every day, and your flow meter is wrong by just 1%. That tiny 1% error could cost you nearly $1.8 million per year. And yet many engineers still use clamp on ultrasonic meters for billing discussions. In this video, I will explain why that is a dangerous mistake. Today we are going deep into a serious technical topic. Why clamp on ultrasonic flow meters are not suitable for custody transfer applications. We will not just talk theory. We will break down the transit time mathematical principle, the uncertainty stack up, API and OIML standards requirements, financial risk exposure, and the cheapest reliable alternative for billing. If you are an instrumentation engineer, metering engineer, or working in oil and gas, water, or utilities, this video could save your company millions. Let's begin. Here is the roadmap for today's video. What clamp on ultrasonic meters are, how they work, why theoretical accuracy is never achieved in real conditions, sources of measurement error, why these errors matter when money is involved, installation sensitivity, fluid and pipe-related limitations, a comparison with other meter technologies, real-world deviation levels, where clamp on meters are still useful, alternative meters for billing, and finally, the practical recommendation. By the end of this video, you will clearly understand when clamp on meters are ideal and when they must be avoided. A clamp on ultrasonic flow meter is a non-invasive flow measurement technology. Instead of cutting the pipe or interrupting the process, the sensors are mounted externally on the pipe surface. These meters work by sending ultrasonic pulses through the pipe wall and measuring the fluid velocity inside. Because they never make contact with the fluid, they are extremely attractive for temporary measurements, audits, maintenance checks in situations where pipe cutting is not allowed. But this convenience comes at a cost and accuracy. To understand why accuracy becomes a problem, we first need to understand how clamp on meters work. Clamp on meters use what's called the transit time difference principle. Here's the concept. One ultrasonic pulse travels downstream with the flow. Another travels upstream against the flow. The difference in travel time between these two pulses is directly related to the flow velocity. This sounds simple, but in reality, the accuracy depends on many sensitive factors. Perfect alignment of sensors, full pipe conditions, clean pipe surface, correct pipe thickness measurement, and proper acoustic coupling. Any slight deviation drastically changes the time difference and therefore the reading. Manufacturers advertise clamp on meters with accuracy claims like plus or minus 0.5% of reading, plus or minus 1% of reading, sometimes even plus or minus 2%. These values are typically ideal laboratory conditions. But in real-world industrial environments, pipe wall thickness varies, rust, scaling, and paint interfere with acoustic transmission. Flow profile is often distorted. Temperature changes affect speed of sound. So the number printed in the spec sheet almost never matches the actual performance in the field. Let's break down exactly where the errors come from. Clamp on meters are vulnerable to multiple sources of measurement uncertainty. First is pipe wall variability. Many pipes have deposits, corrosion, weld seams, or inconsistent wall thickness. Second is poor transducer coupling. If the grease dries, the clamp loosens, or the surface is rough, signal quality collapses. Third is fluid issues. Entrained gases or solids scatter the ultrasonic signal. Fourth is temperature variations. Even small temperature changes alter acoustic propagation speed. Fifth is installation conditions. Incorrect angle, spacing, or lack of straight pipe length leads to major errors. All these errors accumulate, a phenomenon called the uncertainty stack up. Billing and custody transfer require legally traceable flow measurement. This means the meter must comply with strict standards such as API-MPMS, AGA, OIML guidelines, ISO calibration traceability. Clamp on meters typically do not carry fiscal certifications because their accuracy cannot be guaranteed under variable field conditions. Even a plus or minus 0.5% error can cause massive billing disputes, financial loss, and contractual problems. And if installation is even slightly off, the accuracy gets much worse. Clamp-on meters are extremely sensitive to how they are installed. Even 1 to 2 mm misalignment affects results. Coupling gel quality drastically changes signal strength. Pipe coatings like epoxy or bitumen distort ultrasonic waves. Straight run requirements are often not achievable in tight plant areas. This makes repeatability and long-term stability very difficult. Clamp-on meters require very specific pipe and fluid conditions. The pipe must be full. Bubbles, foam, or suspended solids distort the reading. Internal liners, rubber, HDPE, cement, attenuate the signal. Very thick walled or old pipes reduce signal penetration. In billing applications where reliability is mandatory, these limitations make clamp-on meters a risky choice. Let's compare typical accuracy levels. Clamp-on ultrasonic has typical accuracy plus or minus 0.5% to 2%. Inline ultrasonic has typical accuracy plus or minus 0.2% to 0.5%. Electromagnetic has typical accuracy plus or minus 0.5% to 1%. Coriolis has typical accuracy plus or minus 0.1% 0.2%. Turbine has typical accuracy plus or minus 0.5% to 1%. Clearly, inline technologies like Coriolis and ultrasonic spool-type meters provide the highest accuracy and reliability for custody transfer. In real field conditions, clamp-on meters show surprising deviations. Poor installations can cause errors up to 40%. Smaller pipe sizes show higher uncertainty up to plus or minus 3.5%. External environmental vibration adds noise to measurements. This level of uncertainty is unacceptable for billing applications. Despite their limitations, clamp-on flow meters are incredibly useful when used appropriately. Clamp-on flow meters useful for temporary measurements, flow surveys, diagnostic checks, and energy or audit studies. Clamp-on flow meter does not require shutdown for installation, they are completely non-invasive. Clamp-on flow meter also available in portable versions. They are excellent engineering tools, but not commercial billing tools. If accuracy is critical, here are the best options. Electromagnetic flow meters is most economical for conductive liquids. Inline ultrasonic meters is a good combination of accuracy and low pressure drop. Turbine meters or PD meters is suitable for clean liquids. Coriolis meters are best-in-class accuracy for custody transfer. Choose the technology based on fluid type, pipe size, required accuracy, and budget and installation constraints. Here is the final advice. Use clamp-on ultrasonic meters for monitoring, testing, diagnostics, or temporary measurement. Do not use clamp-on meters for billing, custody transfer, or contracts, unless both parties legally accept the uncertainty, which is extremely rare. To wrap up, clamp-on meters offer convenience, but not guaranteed accuracy. They are not designed or certified for custody transfer. Financial risks far outweigh the initial cost savings. Better alternatives exist for reliable and traceable billing measurements. Do you think industries rely too much on clamp-on meters because of convenience? Share your thoughts in the comments. If you found this video helpful, don't forget to like, share, and subscribe for more instrumentation engineering content.